work, but I've still on Wednesday. We're not going to hit any new slides. There is a practical at the end of class here, and we'll get to those and we'll get to that practical in just a moment here. But before we actually go through that, I wanted to take some time here to discuss or finish up these slides here. Hopefully I can get to this. So there. Finish up the rest of these slides and to kind of discuss some cool things that, well, everything's cool in SQL, right? Right? So we've been talking about these constraints here. They're actually formally called integrity constraints because they maintain the integrity of your SQL database. Now what that means is that people are going to be using your database in SQL. They're going to be using your database and they will be querying, of course. But also though, they could be adding data. And when you have people adding data, there's a lot of room for mistakes that could happen here. And so these mistakes could amount to massive losses of time and resources in trying to undo them. And so we have these integrity constraints, as you see on your slides here. Those integrity constraints, these are some of them, there are many others, but these are pieces of information or pieces of code that you put into your table creation, which allows those tables to accept only certain types of information. Now, you're probably thinking, why would I want to create constraints? I mean, this is an open source project and this is all about open programming, and why would I do that? Well, you would do that because the constraints are there to, well, stop certain types of, like, for instance, stop repetition in your table. You don't want to have repetition in your table because that's just a real waste of your time. When you have to, if you're doing a query, for instance, and you suddenly have a lot of records which are exactly the same, then, for instance, maybe you don't, maybe that takes a lot of computational resources, but otherwise, maybe you don't want to have, 1,000 references to John Smith in your database here when there's really only one John Smith that you care about. And so these are constraints that basically, I guess, they prevent the database from exploding in size here by redundant information. But also, though, they make it more manageable because if you know that the information that's going to be entered into a certain table or a certain attribute in your table is text or it's a key or it's something else, if you know that that's what the data is, then your queries can be written in such a way that you can play to that data structure so that you can actually get the information that you want. And also, it reduces the amount of time that it takes for a query to actually happen. This would only be noticeable though if you have like a really large database. So let's talk about a real large database for a second here. When you log into your Allegheny Gmail here, there is a database that has to kick in that when you first put your name in there, a database has to kick in to make sure that what you type in as your password, when it's encrypted, is actually what's in the database. So you type in your password, that password is then encrypted, and then that encrypted text is then compared to what's in your database, or what your password should be in the database. And when your password doesn't work, it's because what you've typed in, when encrypted, it doesn't give you the same encrypted value that's stored in the database. You don't actually store you don't actually store passwords in databases. You store encrypted values of the data here, so that you can compare the encrypted information together. Anyway, it's all text. And so when you have a huge database like your Allegheny Gmail account here, where you have many millions and millions of people, there's a certain lookup that has to happen, and it's very, very quick. It has to be very, very fast in order for the computer to check that you and your password are actually together here. They're actually in the same table, and it's all about you. It's the correct information. And so that lookup has to be very, very fast. I mean, after all, you don't spend any time at all waiting for your login to go through when you type in your password. It seems like it's almost instant. And so that efficiency comes out of data, out of the integrity constraints. So by putting in special constraints in tables so that they are formed correctly, they have a certain kind of information, and the queries play to that certain type of information, like data structure information I'm talking about, then you can enhance the speed. Otherwise, if you just had a database where you had logins and the information could be text, or it could be a string, it could be a float, it isn't really known what it is until the computer actually looks at the thing that you've typed in and then analyzes it to determine that it's a alphanumeric string. It's not just numbers, it's not just alphabet stuff, but it's actually alphanumeric. Then that takes time. And when it's a small database, it doesn't seem like it takes much time at all. But when it's a huge database where you depend on this thing, and you want to have this thing running as fast as possible, then having these integrity constraints really does make things run more quickly. And so with that said, what we're talking about now is we have the, I've given you some examples in our slides here. There's the same ones that we did on Wednesday. We have the null that we've actually discussed before. We have the default, and the default is, for instance, that's to catch errors. If somebody enters information into the database, but they forget one attribute, which has a default marker on it or a default constraint on it, then, for instance, if that piece of information is missing, then it would just store a piece of, a regularly stored value here, like this. In this case here, I'm creating a table called company, and if salary hasn't been entered by either mistake or maybe the information isn't known, then we can have this default value, which is just automatically inserted. Now, you're probably thinking, why would I want to just insert some value here? That's not really information that's not maybe true information. Well, the thing is, though, that maybe you can make a rough guess on how on what the salary might be for people, and so you need some value there. And so maybe this guess that you're creating, this default value in this case, $5,000 or $50,000, maybe that's like your baseline salary, and so you just expect to have some value in there. But when you know the real value, then you go back and change it. But you need to have some value in there in order for some algorithm to go through and work with your database. And so that's why you need to have a default value installed here. Now, the next one we're talking about here is called unique. Where's unique located here? Unique is right here. I hope you can see that. But unique is on age. Now, maybe this isn't the best example of having a unique marker on an age, or a unique constraint on an age attribute. But what it's saying is that if you have, for instance, the same age entered twice, then rejects the whole thing here. It basically doesn't accept the same, if the information has already been stored for that attribute, never mind the ID, the name, the address, or the salary, but if age is already in that column someplace in the table, then it rejects everything here. And so that unique part here might be something you'd use to ensure that you don't have repetition in some particular table where your algorithms or your mining algorithms or whatever you're using that works with this database, they would be thrown off if they didn't have unique values. And so you might use maybe a unique value for a kind of a key. You can have as many unique values as you like, as many unique attributes as you like in a table. But the next one here is called primary key, and primary key is really saying that this ID here is the primary key. And so what I'm saying in code here is that I'm using ID now to connect to the rest of my tables in some way here. That is the basis of my relationship with the other tables. And we've seen some examples before in class where I think the T table and the T session and department table that I put together like early on, like last week's database, we used ID primary keys to create the relationship between all three of those tables. And so the relationship is absolutely fundamental. And so you use primary key to establish that relationship here. And also primary key also establishes that every piece of information in that column is entirely unique. Otherwise, you can't have two different primary keys, or sorry, two different values for the same primary key, because that would suggest that the ratio could be this table some of the time, and then also this table for other parts of the time. And so that's, you wouldn't want to have repetition in your primary keys. Then you have this check right here, and I know that we've gone through these before, but I just wanted to say them again here. But this check is actually very important because, especially when you're working with people actually entering information, supposing, for instance, that supposing people are adding information about how much, like their salary, how much they make every year in this database, and somebody puts in some value which is not a salary piece of information. It's not a number. In this case, the check is very simple. It's just making sure that whatever number they add for their salary is not negative. It's greater than 0. It's not 0 or negative, but you're creating this check, and it says that if anyone enters any information into this table for which the salary is less than or equal to 0, then reject the whole thing because that's not usable information here. And there are some examples that I would like you to try on your own here. You can create this table, and then you can dump this information into the table. This is an insert here, but you'll see that in this particular insertion, I'm trying to insert the value -10, and -10 is really not, it doesn't conform to the check constraint here, and that is that it has to be greater than 0, and -10 isn't. So this record here, the whole thing would be rejected. Now that rejection would actually be a kind of an error message that you'd see on the screen, so that the user who's typing these values in would know. But also that error would also translate if you're using a machine to populate this database, like if you have some kind of piece of code that's doing this, then that error would come back as some kind of a non-succeeded value, which the software would be looking for. And if that value doesn't come back after that program inserts data, then it's going to say, oh, an error has happened here, and then you'd have to catch that exception. And in doing that, you can write code now that creates some way of checking to make sure that values are actually stored, that stored values in here are actually do conform to this constraint. We will go through actually writing code in Python to manage a database system. It's actually quite exciting because you see this, it's like now you have no limits on the size of the data. You can put in this database here. You're not actually worrying about this yourself. You have a machine that worries about it for you. And so your database becomes much, much more powerful when you have some automated system to manage it. Anyway, to be continued. Other types of constraints that we talked about here were, if you're talking about, if you're putting integers into your table, then you'd want to use an int here. And when I say you'd want to use, what do I mean by that? Well, I'm saying that you'd go, for instance, if you're going back to your table here, hopefully you can see this, but here I'm putting in name, and name is a piece of text. It's also not null, but where you see this word right here, text, that is your data structure. And so that's where that constraint would go. And so down here, you'd have text. And so this says up here that name must be text, and it's going to, and it tries to store all information by, as a piece of text. Now, if you enter a number into this thing here, it's probably still going to stick, but that number is now going to be or changed over to a string. And so you're really not able to use the other, what do you call the functions that we discussed on Monday, like the bin, the max, the count, and the sum and the average. You wouldn't be able to use those here because those functions would be built for integers or floats, and this is a text piece of information, and so it wouldn't work. You'd get some, I mean, you'd get some result, but it may not be exactly accurate or may not be correct. Then you can have a char or character n, where you're actually saying that now I'm going to have not just a piece of text here, but I'm having maybe a sentence or some kind of string of a specific length. You might do this for if people are putting their name into a database. But one thing I will say though is that when you define this value of n, it's actually quite difficult because you don't always know how long these values should be. Now, if you're putting people's names into a database, then you have to be very, very careful to give them enough space for their names. I mean, there are some names out there which are very, very long. And when you make this text, when you make the piece of text here a very big piece of text here, one thing you have to consider is that everybody gets that same piece of, or that same size that they can put a name. So if their name is just 2 characters long, or if it's 20 characters long, then it still fits inside the same piece of memory, which has been set aside by character n. And so your database may get big if this value of n is just too large. And so I would recommend kind of going in and seeing what kinds of names would be are going to be going into the system here, because you might find that some of the names necessarily have to be you have to have a very large number of characters to store them. If that's the case, one thing I've seen is when you go to certain websites here, if the name is too long, then it might store the information as a completely different type of. It might, and I don't have it written up here, but there's another one we'll be talking about called a blob, which I think is down. Where is it here? It's down here in 3 frames up from the bottom here. But this is called a blob. If you see this, I can't really point to this where you are, but if you look at where it says consider this in the menu and you move over to the right, you'll see that blob is right there. Blob is a kind of a piece of text that you can it could be it's a piece of text that could be seemingly any size. You might use that to store like a lot of text. But again, as you're using these pieces of, or these constraints, it does contribute to the size of the database when you're using it, and you don't want to have a huge database if you have a limited amount of memory. We have another ones here, numeric. You can specify like a floating point number here, where you have a number of points after the 0. You have real, double precision. These are more things if it's a scientific based number system that you're using. Then you have floats, and it depends what kind of numbers you're keeping track of here. So you might have to look into each one of these things more carefully and see whether that's the kinds of numbers you want for your thing or for your data. And then obviously we have not null that we've seen before. Yeah, the one thing I will say though is that if you use the constraints that are kind of suited for that data, like for instance, this is character n and this is var character or varchar, you'll find that, for instance, character n is actually optimized for working with characters, and so therefore it is faster than varchar, which could be used for strings or for numbers or for seemingly anything. It's like your all-purpose, varchar is your all-purpose kind of storage thing here, but it's not efficient. And that is because every time you enter something into varchar, some piece of software in SQL kicks in the background and checks to make sure that the that you're using a string, or if it checks if it's a string or a number or what it or just checks to see what it is. I think that I wanted to move into the we have some unique constraints here and some other stuff here. I wanted to talk about, for instance, keys and just in a very kind of we're going to move into keys gradually here. But actually, though, we have in this particular employee table here, you'll notice that I have a primary key here, and that is probably a good idea if you're working with identification numbers here. But everything else is varchar. I've used numeric, and I use varchar in this case here because I was thinking that it doesn't really, the database isn't going to be absolutely huge. And maybe I wasn't really sure what size the names are going to be, and I wasn't sure what size the department names are going to be. And so for this information here, I left it as varchar. And if it's a small database, then it shouldn't make any difference at all. But as long as the primary key is established here, then it should be okay. After all, I mean, how big could a database be if you're using this in some university setting? It's only when you have like hundreds of millions of these days on software or on hardware that we have, when you have like hundreds of millions of entries into a database, that you start seeing like some real slowdown where it almost comes to a halt when you're doing a query. But for the small databases, though, just for this class, it doesn't really make too much of a difference here. So we're going to talk about primary keys for a second here, and I think that one of the best ways of actually kind of illustrating primary keys is to just show you an example here. But the primary keys are essentially used to remember to make sure that that information in that column, in that attribute, is absolutely unique, and that's necessary because we're going to be using these primary keys to establish a relationship between multiple tables. We'll get to foreign keys later on here, but this contrasts with foreign keys where, for instance, a primary key is a key that you have in the table where you are right now, whereas a foreign key is a key that that table has, or that a table has, which can be used by other tables. So I'll just read this here: column or columns that references a column of another table. So really, you're saying that if I'm creating a very established relationship between two tables here, I'll say that the first table has a primary key, and the second table, to ensure that that relationship exists, the second table also has a primary key, but it's going to have a foreign key, which is kind of a hardwired link to the first table, so that that relationship is always intact. And I would do that because I want to make sure that anytime anyone's using this database, that relationship is continually checked with that information to ensure that nothing is being entered into the tables which could somehow upset the relationship. And we'll see some examples of that later on. So as you've noticed, I have this sign here, top secret. I guess maybe if this were really secret, maybe I shouldn't have written top secret, just because now everyone knows. So be sure to tell everyone it's a secret. We have two different tables here that I wanted to show you. And what I'm going to do is I'm going to just drop them into I'll copy them if I can here. And then I'm going to drop them into oops, that's not where I am. That's me again. I'm going to go here, and I'm going to just establish a place where I'm going to be working here. So where am I now? I'm going to go into I'll just make a directory here. It's always a good idea to make a directory where you're going to be working, because you might want to have a whole bunch of files here. Then once you've finished working here, once you're sure that your database is working as it should, then you can go ahead and just remove the you can remove those files or copy them into your repository or something like that. I mean, actually, if you're testing things out. But if it's a deliverable, I would say just work in the repository and just submit whatever you have in there. I'll just call this agents. agents DB. I think you have a build file actually in your sandbox here. But remember though that when I type in SQLite 3 followed by a file name, what that does is that creates the database, and anything that I add down here is going to be saved to this file here, and I'll show you how that works. But you have to exit the file though. You have to, and you can't just close the window and have it go away and disappear, because then you'll lose things. So I'll paste in my table that I've just created here. No such table, that's fine. Oh, I have to copy this again. Sorry, everybody. Let me go back and do this. Let's see, create. Something happens when I do this. Oops. Why does that not work now? There's, you know what, I have to tell you what I have to do. I have to go through and find out, I need to add a space between here, and I think that's it. There we go. So I just put a space in right here between key and last name. I always look for missing spaces. For some reason, each time I copy and paste anything from my slides, spaces are missing. So now anyway, I have agents in here. I can type in schema and type in agents, or agents, GENTS1, there we go. And this is the schema. Now remember that you want to type in the word schema for each table that you're working with if you're writing a query, because your query is going to be centering around these attribute names. And if you don't remember what the attributes are, then it's difficult to write the query. So that's my first table here, agent1. Now let's go back to the slides and then see the other table here. The other table here, actually let's talk about agents1 for a second here. But you'll see that there's this constraint agents PK here, primary key. This is basically saying that I have this key now where I'm looking at the first and last name, the last name first name last. But I'm using my key is actually being created out of the first and last name of the people who are entered into my database. Notice that there's no ID here. This is just another way of writing a primary key, but I'm using, this is a super key, in other words. I'm using this last name in conjunction with this first name, and that becomes my key. And so if anybody comes into my database here who has the same last name and first name, if I have John M. Smith and John W. Smith, it will reject the second John Smith because the name, the first and last name is the same. Now this piece of code right here, constraint agents PK, this is my primary key, I need to give it some name so that SQLite can work with this here. I have to tell SQLite that the primary key is formed out of these two words, but this is the name that I'm using to reference it, agents PK. And this is where this, and constraint just says, coming up, you have this new word here, which is not a piece of data that someone's entering, but rather it's data that they've already entered, which we're now going to make into a key, and that's this information here. And so that is a way of using primary keys here, where you can just say, well, I have information in my table. I'm going to combine this attribute and that attribute and this attribute, put them all together, come up with a new name for this whole thing, and then say that's my primary key. You would do that if you don't have an ID. Notice in this table here, don't forget, this is top secret here. So we don't have the IDs for some of our agents here. We just have their names. And so we're creating a primary key out of the stuff that we do have, which is their last name and then their first name. This table does not accept any redundancy. So let's just go ahead and, before I do anything here, let me just put this other table in here. Hopefully I can get this without any trouble. And then we'll add some data, and I'll show you about this redundancy and not redundancy. So if I go back to here, and I paste it in there, I'm gonna make sure that there's no spaces. Okay, it seems to work. Okay, so I have agents 1 and agents 2. Schema, I can actually type schema, or I can type in agents 2 and see what happens. By the way, if you type in schema with the table name or schema by itself, and you put a semicolon at the end, then you don't, it doesn't seem to work. So I don't know whether that was a fault of when they designed the SQLite here, but it's just, to me, I always have to think, am I adding a semicolon or am I not adding a semicolon? If I put an agents, for instance, here I get the schema. But if I put a semicolon at the end, I get nothing. And so I don't know why that's I don't know why that's there. I think that might be built in from some days gone by when that was important, but now it just seems kind of just unusual that you don't add a semicolon. But maybe that's just me. So going back here, we have some data that we're going to add here. So you'll see that I have two insert statements down here, one that goes into agents 1 and the other one that goes into agents 2. And so we are going to be populating our agents 1 table and our agents 2 table. And so going back here, I have my agents 1 and agents 2. So let's just go ahead and put this information in here and see what comes up. So everything seemed to be okay. I don't see any error messages here. And so I can check to make sure that my tables are obviously still there. But I'm going to do a search here on what's inside here. Before I do this, I always type in schema. It's just like just so you have it there in case you need it. But remember, your selection is going to be select, or what's wrong with my type today? SELECT select star from agents 1. Okay. So I have Bond, James Bond, who lives at 123 ABC Street. And by the way, everybody, keep that secret. If this gets out, what happens in Alden Hall stays in Alden Hall. Or not. You can tell everybody it's okay. I just made this up. Don't tell me that. So the next thing is the same data goes into each of these tables here. The first table, the data stuck, and the second table, the data stuck. It's exactly the same data here. But if I went ahead and entered this information again, let me see if I can just paste this back in here again. Let's just see whether it still sticks again. So if I put in, for instance, insert into table into agents 1, I push this value, and you'll see that I get an error now, and it says, aha, the unique constraint failed, agents1.lastname, comma, agents1.firstname. And so you're probably thinking, what does that even mean? Why am I getting a constraint failed here? It worked a second ago. Well, it doesn't work now because remember that in your schema, in fact, let's go back to the slides here. In your schema for the first agents table here, you are saying that your primary key is going to be in conjunction, a conjunction of the last name and first name, which is going to be called agents_pk. So if the same last name and first name in the same tuple here are entered twice, regardless of the address information here, it's going to be rejected because your primary key is now based on the premise that you have one last name and one first name combination of that type. Now, if I went ahead and I'll just change this, since the query is exactly the same. Oh, sorry, it is the same here. You'll see that I actually inserted also into agents 2. You'll see that agents 2 actually stuck. That means that the insertion went okay. So I'll do a select all from agents 2 and see what's in there. So for instance, agents 2, I'm getting, actually, did this actually stick? Let's try this again. Oh, you know what? I have to do it. Let me just do these individually here. Maybe that would be helpful for me. So I'm going to go back over here. Hopefully you can, there, sorry about that. So I can put this agents 2 in here, and you'll see that, there we go. So now if I do a select star from agents 2, you'll see now that agents 2 can take this insertion as many times as I like. And that's a lot of redundancy here. And when I do a select here, I can see that I'm getting this, all this stuff is exactly the same. Now, while that's not really a problem, we can write queries that will trim out that redundancy. In fact, what I can do is I can always write, for instance, hang on a second, schema agents 2 here. I can say, give me, for instance, select, I'll call this last name. I can type that, or if I want to get like a unique value of what's going on in there, I can type distinct, and I just get bond, one bond. So the thing is though that we can write code that helps us to overcome the redundancy that we get in these things, but actually though our database is going to explode with data here. Now going back to agents 1 here, we'll see that we only ever get one database, or only one reference for James Bond here, and no matter how many times we try and enter this thing here, and like I'll change my insertion code here, and you'll see that each time I do this, it still says constraint has failed. But if I said, for instance, James, I'll call it Jim Bond, that should work because Jim and James are two separate names. So what we have established here is that we can create primary keys not just out of using IDs, but for instance, if someone gives you a database and they say, I want you to create a database and make this usable, and I want relationships, and I want all this stuff to work, then you could say, well, how do I create the relationships in my database? How can I put this all together? And you could do that just by using this this constraint here to create a primary key. I think that maybe that's enough said on this. I think you all get it. If you have any questions over this whole thing, then I'd recommend just playing with the code for a while, just seeing what you think, and then if it's if you have questions, I mean, obviously let me know, and I'll be glad to help. But it's actually quite a sophisticated piece of software engineering to put this thing together. So you can take now any piece of information, any data that someone could give you, and take any piece of information out of that data and use that to establish a primary key, which was something that you couldn't do if you didn't have some kind of an identification number or a serial number or something else. Serial number is actually very important. One thing that comes to mind is that if you look at a dollar bill, each dollar bill has a number on it, and so that number on that serial number on that dollar bill, or any money that you have here, legal tender currency, that number is entirely unique. That means that there's a database that the government runs, and every single dollar that they've printed out ever, every serial number, is included in that database. And so that is obviously what they would use as a primary key to keep track of all the money that they've ever printed out. They'd use that to curb counterfeit money and all that, so they can check to see if they find that there's money coming in that they've already entered into their database, or if there's a number which is coming up again, then that other bill that they're looking at must be counterfeit, though, because it's not a unique number. And so primary keys are actually used to establish certain types of security, but also, though, certainly to create the relationships between the tables themselves. These are some tables or some information I always add, that I'm adding at the end here, that I always type in here. For instance, I always have the .tables, .schema. You're going to use these commands all the time here, and so please commit these to memory here. And always, I mean, I know you know these commands already here, but every time you're writing a query, though, it's a good idea to type in .schema so that you know what the actual attributes are that you're going after for your specific query here. So the moral of the story here is that we are talking about primary keys where there's no redundancy in our column. And remember, there can only be one James Bond, which is it's kind of funny when you see this picture here. There's all these different guys who play James Bond in this. But there's only one James Bond. And so you would use that primary key to ensure that there's only one James Bond here, regardless of all these gentlemen who are James Bond. Okay, so this brings me now to the activity. I have an activity plan for you today. This is a deliverable. I'd like you to submit it, not today, but by next Monday, 12 o'clock noon. I'd like you to create your own database. That is it. Find your own data. You can make the data up. You can do whatever you want. It could be information from, I don't know, from movies, or you can make it up, or it's people you know. It could be anything. It doesn't matter. I want to know that you can create a database from scratch here using similar types of code that we've been using before. This is very similar to your lab, for instance. But don't use your lab data. Use other data. Be creative in this whole thing here. So I say obtain or fabricate data for the project. At least I want to have at least 5 rows of data per table here. So it's not a huge amount here, but when I do a select star from the table that you create, then I have like 5 different things that pop up. I'd like you to write a builder code here, like a builder file, like what you've had in lab here, to actually create this database, so that when I'm running your database, I can just use your builder code and recreate the database that you've come up with. And in your builder code, I'd like you to actually have insertion commands here, which will allow me to just insert the data without having to do it without doing it manually. So for that, you can use the import statements, or you can just have the insert code from SQLite. And then I want you to have 4 queries. where you are combining 2 or 3 of your tables. Remember, I'm asking you to have 3 tables, but I want you to have queries where you're connecting 2 or 3 of those tables together. I mean, do have one, I'll be looking for one that has all 3 tables connected here, but I want you to have queries where you can, where you're demonstrating that you can actually find information here. And in your queries, I'll be looking to see that that the relationship that you choose is actually being, is in the code of your query so that the tables are being connected. And you're not just getting a Cartesian product of all the tables in your database when you run a query here. This is to be submitted by your classroom or activity repository here. And let me just take you through that for a second here. Hopefully you can all see this. We're going to be using this same GitHub Classroom repository link for all the practicals that we do. We'll tend to do practicals on Friday, just to kind of keep our skill set up here. But when you click on this link here, oh, I'm going to lose my slides, aren't I? Oh no! There we are. I just lost my slides. I just lost my slides. Maybe I can bring them back. There we are. Bring them back in there. Okay. Okay. When you click on that link here, it'll take you, just like in a lab here, it'll take you to this repository. And when you click on this, you'll find there's a whole bunch of files in here that you can look at. You're going to be working in practical 01. But when you move forward here, the next practical, I'd like you to create that directory yourself and then just submit everything to this same repository. You're just going to be submitting to the same thing all semester long. And the next one, I'll tell you I'll remind you to make a repository name for it, a directory name. But it's probably going to be like 02 practical or 03 practical or 04. And so there'll be instructions. But when I go through and give you a checkmark grade for this, basically just says, yes, this is in, and to make sure that all the deliverables are intact, I'm going to be checking these directories here. And so I'll tell you what repository or what directory in your repository it is to use. Now, one thing I wanted to take you through and just show you, I'm going to go ahead and just clone this in here. I don't even, you can't see when I click on anything, but it's really bummer. But when I click on this button here called code, which is the green button, or maybe, can you see that? You can see this sometimes, but not always. Oh, I guess you can now, okay. All right, good news. So when you clone this thing here, I'm gonna take you back and show you some new commands here, and I'm really speaking to the people who are, and by the way, exit your database, type in .exit, and then you're done. Everything is saved. You can see that your file is there. That's the work in my database. Just one more thing. If I go back into this, if I go back to my database here, and I type in .tables, you'll see that everything is there. In fact, I even have my data still there too. And so that's why you want to type in .exit so that it saves your work if you're writing your database freehandedly. Now, I'm going to create a repo here. I'm just making this here, but you probably would want to put it someplace that's a little bit more logical, someplace that you can actually find it. Maybe categorize it by your class here, whatever it is. But when you just type in, for instance, git clone, and then you dump in that link that you have there, then you'll get into this. You'll have a new repository is created here, and this is called the practicals, and it's going to be followed by your name. This is something you already know. It's very similar to how labs work. But there are some new commands in here. These are your new Docker commands here, and I'm hoping that they work for everybody here. So I'm speaking to the scholars of this course who are using Windows machines, and I think that these things should work. One thing I have found though is I was up late last night working on a computer that has Windows on it. I did acquire a machine that has Windows. And I've noticed that if you've installed in the past Docker Toolbox, and then you install the new Docker for Home software, Docker Desktop for Home, the Toolbox code interferes with the new installation of Docker Desktop. And so I recommend to remove or uninstall Docker Toolbox, and then once that's gone, then Docker should work. I mean, it should work. So when you run your code here, if you're using a Windows machine here, you're going to be using this command here called build_win. And basically, the command is very similar. You have to have this Docker file in the directory where you're working. It must be there. And so that's why I put all these things into the main directory of this practical, so that you can get to this. Obviously, if I run this Docker win here, it's not going to work because I'm using a Mac. But so I'll run the code that I have now, which is basically the build command here, which is sh. That is a Linux or Mac command that you can run here. Now, if these commands don't work right out of the box, you can always type in chmod or change mod plus x followed by build .sh. Remember, this is for Linux. This makes the file runnable. And I'm going to do the same thing with the other one here. chmod plus x. That means that I can now run this. I can now run this. I can run this file like this. Before I couldn't. It just makes the file. In fact, just FYI, if you want to see something here. When I type in ls minus l, when I'm looking at my builds, you see all these x's right here, like this x right. You see that? Maybe you can. It's hard to see, but these x's here means it's an executable file now. Whereas before, the file didn't have the executable attributes, and so it wouldn't run. So anyway, that's this command here, chmod. And if you forget that command, just let me know. Send me a Slack message, and I'll let you know what it is again here. Now I'm going to go ahead and just run build, and it may ask me for my password when I'm running this thing here. If it does, then just type it in. It's just to build the container. But otherwise, everything's exactly the same. I'm putting everything into two different file names. Before I just had one build my container, but now I'm having everything in two because I think it's easier to kind of manage. It's easier for a teaching point of view here. When I ask somebody to type in a build command or a run command, I can see where the error happened if it doesn't build or if it doesn't run. Otherwise, the file would just return an error, and I wouldn't know where that error really was. Anyway, when you run this on your machine, though, it's probably going to be taking up a lot of time here. You'll see a lot of other things going across your screen. That's okay. You'll see that. It's building the container. And you want to see something that looks like this. You want to see that your container is building. Then the next command you're going to be typing in is on Linux here, run sh. If you are using a Windows machine, you would type in run. Sorry, if you're using Windows, you just type in build ._win like that in this directory, and it should build your Docker if you haven't got Docker toolbox in there to interfere. Please let me know how that works. And then once you finish on a Windows machine, when that's come to an end, when the container is built, you type in run _win, and then that should actually engage the container and run it for you. But on my Mac here and on Linux, you can just type in run.sh. sh stands for shell. So that's a shell command. When I run this, it takes me into my Docker container. And so here I am inside my container. And the nice thing about this is the reason why we're running this code here, these scripts allow you to go into your container and to look outside and see the files that are local to the directory where you were when you first ran the container. Otherwise, you can create a container which is completely empty. There are no files in there. But really what this is a kind of it's a mounted drive inside Docker, which allows you to access the files that exist in the directory where you were when you ran your commands. In other words, right out here. Oops. I have to add, when I leave this container, I have to add my password here. And the reason for that is because you'll notice that each of my, and this is a Linux thing, you won't have that password in your Windows. But in your Linux command, though, for instance, you have your name. Every time you create a file here, the user, the user's name is attached to that file. It's a security thing, so that, for instance, if anyone gets into your account from another account on the same machine, their name is different from yours, and they can't read your files. So what happens in a container is that when you create a file, the container doesn't belong to you, it belongs to root. And so all files are created basically in someone else's name. And so this piece of information, or this piece of code that I have here at the end, where you have to re-enter your password, what that's doing is it's taking out, it's assigning the files that were created in the container back to your username. And I can show you what the code looks like if you're interested in seeing what that looks like. It's using a command called chown. Excuse me. And chown just says, take all the files that are in this repository, in this area here, and give them to the user of this computer, which in my case is Bonham-Carter. Excuse me. Anyway, so that's what this is doing. This is nothing you'd have to worry about in Linux, or sorry, in Windows, and so it should be okay. So if you could, once more into the breaches, everybody here. If you have a Windows machine, please uninstall Docker Toolbox if it's installed. I know that if you're in previous classes in this department, we installed that. And we found out that that didn't work. And so if it's still there, please uninstall it and then try and run these commands here and see whether it builds your container. I'm crossing my fingers. I'm even crossing my toes here. I mean, everything is being crossed here. And so if this doesn't work, I need to know so that you can get into your container. You need to get into your container to do your work for your lab. And by the way, on the labs, if you find that you need an extension, I know that we're all dealing with some pretty unusual things this semester here as a result of COVID-19. If you need an extension, please let me know, and we can talk about that, okay? Just because I know that we're all very busy with different things happening to us. And if you're having trouble with your container here, then I can give you well, we can talk about an extension. I'm sure that's very, very simple to do. Anyway, so that's really it though. I'm going to go back to my slides here. Where are we now? We're here. I put in the in this. You'll always have this slide for your practicals. I'll always give you the commands that you need to know. Now I know that some of us may not be super familiar with Git just yet. That will come, but I'll always put these commands in here as I will in the lab, so that you have this this to remind you of how you submit your homework. So what I'm going to do now is going back to my repository that I've just created here. Let me just go into my 01 practical, which is what I'm doing for this week here. I go inside there. I find another directory there called deliverable. Hopefully you can see this, good. And inside deliverable, I have my builder file. I'll just use Vim here to open it, but I could use Atom if I wanted to. I should be in my container when I'm working on this. Let me just get out of this here and let's just do this real here. Okay, now I'm inside my container. I'm going to go into my practical, deliverable. I'll do my work here. I have my builder, and builder is going to be a file it's just empty. I want you to put your table code up here, like the creation tables, the creation of the tables here. There are 3 tables. And then I want to have your insertion code here, whether you're inserting using the inserts or you're using the import statements. Now, if you need import statements, you have code that's in our last lab. You can use that. And then at the very bottom of this file here, I just added this here. This is how you actually compile your database. So I'm assuming that you'll call this, you won't change the name of the file here, and that your database is going to be called mydb.sqlite3. Now, also, I know this sounds like a lot of work here. I won't spend as much time going through every single practical here, but I want you just to kind of have an idea about what to expect in these practicals here. You have another file here called query, and for your 4 queries that I'm asking you to put together, that's really all that there is here. Don't forget to add your name, please. I ask you to add your name because when I pull over your work here, I pull out your files here, and then I sort them automatically. And so if it doesn't come with a name, then I just have a serial number that I have to go back and check to see where it comes from. So please don't forget to add your name right up here. I want you to add, for instance, I just add a space under each one of these things here, and then add your query under this area here. So like put a space between these 2 different things here. But I want you to, in your own words here, just to tell me what it is that you, what are you actually working on? What is your what query are you actually looking for here? What's actually coming out of this? And then I want you to actually add the query itself right down here. Okay, that is it. There's nothing really different about any of this stuff here. Okay, so anyway, I think that's probably the end of the over time anyway though. But you have the whole weekend on Monday to do here. Please just put something together here. It doesn't have to be a super exciting a database, but I do want to know that you're able to create a database in Docker. Otherwise, it's not going to go well for your lab if you can't get into these things. I need to know that I can help you get everything, get your software in order as best as I can, so that you can continue your work in this class here.